Alright, welcome back guys. We're going to finish up 3.7, and as I alluded to previously, we're going to be looking at graphing a system of linear inequalities. So this is similar to a system of equations, but to solve a system of equations there is one unique point, okay? Well, in most cases, there's one unique point, one value for x, one value for y, etc. But with these systems of inequalities, like if you look down here in example 5, there are many ordered pairs that will satisfy this system, and that's what we're going to try to figure out, okay? And we're going to do this by graphing, okay? We're going to graph each of these inequalities separately, and any region that's intersected or overlapped, that will be the region that contains the solutions to both of the inequalities, okay? Now let me give you a little bit of motivation behind this. So here's an example in which we might be interested in solving a system of inequalities. So let's say a store owner needs to order a certain number of pens and markers, and these could be anything really. It doesn't have to be a store owner, it could be you. A minimum number in order to receive free shipping, okay? So you have to buy at least so many. While also, you've got this additional restraint here, while staying under a total budget, okay? So here I came up with a couple equations, or inequalities. So P would represent the number of pens, M the number of markers, and these would probably be boxes of pens and boxes of markers. And let's say the minimum number of items that we need to order in order to obtain free shipping is 40. So we want the sum of the number of boxes of pens and markers to be at least 40. Okay, so we need the number of boxes that we order to be greater than or equal to 40. And then furthermore, let's say that the each box of pen costs $2 and each box of markers costs $5. And so our budget limit is $100, so we need, the cost for pens plus the cost for markers to be less than or equal to 100. So then the question then becomes, okay, well, how many boxes of pens and markers should I order, okay, such that I'm at least ordering 40, and furthermore, that I'm trying to stay at or below my budget. Okay, so this would be an example. And sometimes, solutions like this or systems like this may not even have a solution. This might be impossible. But anyway, that's a little bit of, I guess, real-world motivation behind being able to do this. Okay, so to graph this system, we're going to graph each inequality individually, and then we're going to shade the area where the shaded regions of each inequality overlap. And that region that gets shaded twice will be the region that satisfies not just one of these inequalities, but the actual system. Okay. All right. And fortunately, guys, both of these inequalities are in slope-intercept form. So I'm going to go ahead and write them as equations. Okay. So you can see here, my y-intercept, b in other words, is going to be at 1 on the y-axis. Let me scroll down some. And then the slope is that same understood 1 over 1. Okay. So I'm going to plot my y-intercept at 1 on the y-axis. And then my slope dictates that from this point I'm going to go up 1 and run 1. So that'll put me right here. Now I'm going to look back at my inequality, and I can see that it is a strict inequality. And consequently, I will draw a dashed line, or at least try. Okay, something like this. Okay, and now I need to figure out where to shade. Well, this says that y is strictly greater than x plus 1, so I'm going to shade above. I'm going to be shading all of this region here. Okay, so this region that I'm shading satisfies that first inequality. Now, let's graph the second one. We'll treat it like an equation initially. And these two terms, guys, I'm going to swap the order because I want it to be explicitly in slope-intercept form. So now you can see our y-intercept is going to be at 2. And there's a low understood 1 here, but our slope in this case is negative, so we haven't actually seen one like this. So I'm going to put a point at 2 on the y-axis. And because my slope is negative, it dictates that from this point I'm going to fall 1 and then run 2. Okay, so go down 1 to the right 1. That puts me there. Now I need another line, but it needs to be solid. Where did I write that inequality symbol there? Anyway, this is a non-strict inequality. Okay, so when I draw my line, let me see how well I can do this. It's got to be solid because we're including all of those ordered pairs that are on that line. Now, where do I need to shade? Above it or below it? Well, it says that y is less than or equal to it, so I need to shade below that line. So for that, guys, I'm going to get red, different color here. Oh, I don't know why that does that. Like goes if I go off the screen or what. Anyway, yeah, see what that is. Okay, so some things are okay. All right, now having done that, you're looking for the area. There's always going to be 4 regions here. Which region got shaded twice? Well, it's this region. Okay, so this region right here contains the solutions to that system. And in your homework, this question is multiple choice. Okay, so you won't actually have to graph 2 different lines. But this section right here would contain the solutions. Now, in the context of this example problem, you could graph both of these if you wanted. You would have to let maybe the x-axis represent the number of pins, and then maybe the y-axis represent number of markers, and so you would have to solve each of these for m and do it that way. But it might be a small little region, meaning there is some variation in the numbers of boxes and pins, or boxes of pins and markers that you could get, such that you're getting at least 40 to get the free shipping, but also staying within your budget. Okay. Yeah, but like I said, with some of these restrictions, I don't think that region is going to be very big, just by looking at these. All right. Okay. So the last thing I want to do is just take a peek at the homework. Well, I don't think I have this one assigned yet. I have to come in here as an instructor. 3.7. Preview it. Alright. Okay, let's see. Let's go to question 2. Well, no, I don't want to do this one because I'm going to have to solve. For y first. So let's go to question 1. Okay. Alright, this one, I'll zoom in a little bit here, make it a little bit bigger for you guys. Okay, so you're going to click here again. Now for the most part, this one's already in slope-intercept form, guys, so you're going to put a point at -4 on the y-axis. And then use your slope. It's an understood 1, so 1 over 1. So you're going to rise 1. Well, it's hard to see here, but I'm rising 1. I'm going to go to the left, to the right 1. Okay, that's where I'm going to put my point. Now, by default, it's solid. So if you want it to stay solid, you don't do anything. But if you want it to be dashed, then you come over here and you click on this key. Now it's dashed. And we need it dashed. And furthermore, this says y is greater than, so I need to shade above this line. So to shade, you're going to grab the paint bucket. You're going to drop this bucket in the region that you want shaded. Okay? And so that's what I really wanted to show you. Alright, and you'll save it and hopefully get it correct. Okay? Alright, so that concludes 3.7 on these linear inequalities. Alright guys, so I will see you in Module 2. We're going to start looking at, we're going to focus on quadratics a lot, quadratic functions and their behavior. So anyway, I'll see you there.